In this video we're going to do a proof of the cosine rule formula. I want you to understand that this is quite a complicated proof. Some people struggle to follow it, and if you struggle with it, it's quite okay to not worry about it and just use the formula anyway. Now on our triangle we're going to label the three angles capital C, capital A and capital B. We're also going to label the sides lowercase c, lowercase b and lowercase a. The next thing we're going to do is draw a dotted line to represent the height of our triangle. It's going to meet the base BC at right angles, and we'll label this as H for height. We also want to label the point at which the red line meets the line BC, and we're going to call that point P. We also need to know the distance from C to P. We're going to call it X. And we also need to find the distance from P to B. And the way we're going to do that one is we're going to remember that the length from C to B is A. And if we take away the X, we get A minus X. Now let's go and look at our proof. And we're going to use Pythagoras Theorem to get us through this. There are two triangles we can see inside of this large triangle. The first one I'm going to label in orange with sides B, H and X. And using Pythagoras Theorem we're going to say, well, B squared must equal H squared plus X squared. We also have another triangle on the right which I will colour in pink. This one has three sides, one of which is a little more complicated. We've got a side of C, H, and the third side is A minus X, which makes it a little more difficult. For this one, C squared equals H squared plus brackets A minus X squared. What I'd like to do now is expand my brackets, because brackets can be a little hard to work with. To do that, I'm going to write A minus X twice rather than using the square. And then I'm going to use FOIL. A times A is A squared. A times negative X is negative AX. Negative X times A is negative AX. And negative X times negative X is positive X squared. Also, because I've got negative AX twice, I can just write negative 2AX to simplify a little bit more. Okay, what are we going to do next? Well, you'll notice that both of our equations here have an H squared in it. And we're going to play on that. We're going to focus on getting that H squared on its own. How am I going to do that? Well, for our first formula, we'll call these number 1 and number 2. For our first one, I'm going to subtract the X squared on both sides. It's going to cancel X squared. And it's going to give me B squared minus X squared equals H squared, which is what I'm looking to do. I'm trying to make it in terms of H squared. I'm also going to do it for the second one. This one's going to be a bit trickier. I'll start by subtracting A squared on both sides, giving me C squared minus A squared equals H squared minus 2AX plus X squared. Now I think I'll subtract X squared on both sides. That'll give me C squared minus A squared minus X squared equals H squared minus 2AX. Now I'm going to add 2AX on both sides, which is going to get me to where I want to get. So C squared minus A squared minus X squared plus 2AX equals H squared. Now what you'll notice is our two formulas both equal H squared. This formula here and this formula here. If they both equal the same thing, then they must equal each other. Therefore, B squared minus X squared must equal C squared minus A squared minus X squared plus 2AX, like so. Another useful thing we can do here is we can add x squared on both sides, and we're left with something that's much simpler. B squared equals c squared minus a squared plus 2ax. I want to rearrange it a bit more because I want it to be in terms of c squared. So I'm going to add the a squared on both sides, giving me b squared plus a squared equals c squared plus 2ax. I'm now going to subtract 2ax on both sides, giving me b squared plus a squared minus 2ax equals c squared, because the 2ax has been cancelled. Next thing I want to do is find cos of c. And whenever you do cos, it's always adjacent over hypotenuse. And if we look at our c angle, our adjacent is x and our hypotenuse is b. So cos c equals x over b. And if I multiply by b on both sides, I'm now left with x equals b cos c. And this is a key part of our formula. This formula here and the formula on my bottom left, like so. We're actually going to substitute our x into this formula. So, looking at our formula on the left, I'm going to start writing it down. B squared plus a squared minus 2a, and where we can see the x, I'm going to replace it with this. I'm going to replace the x with b cos c, which equals c squared. And this is the cosine rule, which is normally written as c squared equals a squared plus b squared minus 2ab cos c. And that is how the formula came about. Now, there's also another formula, which is the one we use when we find angles. So I'm going to go to a new page, obviously, because we've run out of room to do this. And all we really need to do is manipulate the formula and just move things around a little bit. I'm going to start by adding 2ab cos c on both sides. That will cancel out the 2ab cos c on the right, giving me c squared plus 2ab cos c equals a squared plus b squared. Now I'm going to subtract the c squared on both sides, giving me 2ab cos c equals a squared plus b squared minus c squared. And finally, I'm going to divide by 2ab, and I'm just going to leave it as a fraction. This cancels out the 2ab, giving me cos c equals a squared plus b squared minus c squared over 2ab, which gives us the other formula that we use for finding angles. And that concludes our proof of the cosine rule.